Hi everyone, Geek37 back with another video, and this is part 31 in my series on exploring the heptagonal triangle. Now what we're going to do is we're going to do a calculation similar to the one that I did in my last video, where it was a series of sines squareds and products of sines squareds equaling a specific fraction after we added them together. This time we're switching it to cosines, and I was going to solve it very similarly to my last video, where I would set up an equation of s squared equals s1 plus m. No, I found an easier way to do it, and I wish I had done this before. So here's what I'm going to do. As you can see there, I have all my cosine ratios written down, and I proved those in one of the earliest videos in this series. So what I'm going to do is I'm going to replace cosine squared of pi over 7 with b over 2a, quantity squared. And where there is cosine squared of 2 pi over 7, I'm going to replace that with c over 2b, quantity squared, plus b over 2a, quantity squared. And the cosine squared of 4 pi over 7 is negative a over 2c, so we'll square that. Make sure to put little dots in here to show that they are going to be multiplied after we do the squaring of each of those ratios. So cosine squared of 2 pi over 7 is c over 2b, quantity squared times negative a over 2c, quantity squared. So this sum of cosine squared of pi over 7 times cosine squared of 2 pi over 7 plus cosine squared of pi over 7 times cosine squared of 4 pi over 7 plus cosine squared of 2 pi over 7 times cosine squared of 4 pi over 7 works down to a series of squared variable ratios that will make this calculation much simpler. So what we'll do is now we will work each of these parentheses down, so we'll get b squared over 4a squared times c squared over 4b squared plus b squared over 4a squared times a squared over 4c squared. Now remember that second or that fourth set of parentheses there's that negative a on the top. Well, negative a times negative a is a squared. Two negatives will make a positive. Time plus c squared over 4b squared times a squared over 4c squared. And what happens is the c squareds will cancel, the a squareds will cancel in the middle, and the b squareds will cancel at the beginning. So here's what happens. We will get c squared over 16a squared plus b squared over 16c squared plus a squared over 16b squared. Now notice here, this is a lot simpler than what I was planning on writing out before. You'll see that we have a series of squared ratios, and you can probably see where this is going quite easily. We notice here that we have the 16s in the denominator that I'll be highlighting here in yellow. I can actually pull that out, make that 1 over 16, and what's left on the inside is c squared over a squared plus b squared over c squared plus c squared over a squared. Now, you have seen this series of ratios before. C squared over a squared plus b squared over c squared plus c squared over a squared. I proved this in a prior video, and all that equaled 6. So we can replace this complicated set of parentheses with 1/16 times 6, which is 6 over 16, which both 6 and 16 are even. We can divide the top and the bottom by 2, and we will get 3/8. So the answer to this complicated expression, cosine squared pi over 7 times cosine squared 2 pi over 7 plus cosine squared pi over 7 times cosine squared of 4 pi over 7 plus cosine squared of 2 pi over 7 times cosine squared of 4 pi over 7 equals 3/8. Now, once again, I was going to solve this like my prior video, where I did the sine squared of pi over 7 times the sine squared of 2 pi over 7, etc., and I got 7/8. The thing is, I had to solve it that way because if I had tried doing it with its variable ratios, I would have gotten a variable squared expression, which I don't easily have the answer for. It's easier to have done it that complicated way and then get the answer to that variable expression, which I will do a video on later in this series to get to another calculation. But for this particular calculation, I found instead of going through that route of s sub 2 squared equals s sub 1 plus 2m, I found this a little easier to write down, and it didn't seem to take as long to work out, even though this video is probably about as long as the last one. All right, I hope you enjoyed this video. I enjoyed making it. This is Geek37 signing off.